All right. Hello, everyone. Welcome. Hello, hello. All right. OK, so welcome to Recursion is a Harsh Mistress. So this talk is about recursion and about scanning the internet and how when you pair those things together, you get all kinds of crazy bugs. So these are not bugs that I exploited. They're actually bugs that exploited me. But it's sort of a fun talk. Basically, it's going to be a peek behind the scenes of making a hacking tool. All the disasters that sort of befell us during this process, demos of things failing. You're going to see a lot of those like pretty orange nodes that you saw at the beginning. Fun facts about recursion, like sort of why everybody knows what recursion is, and we're in cybersecurity, we know what it is. We kind of know that it's good for OSINT, but hardly anybody uses it, and sort of why that is. But also, we'll learn how if you could use it, it could give you superpowers. And like I'm like very serious about this. So we're going to be talking a lot about recursion. And when I say superpowers, like basically, it will give you an edge as a red teamer, as a blue teamer, and even like as a threat intel person. So as long as you are interacting with the internet, you're gathering data from the internet, it will help you. Yeah, also disclaimer, I talk fast, I go fast, there's 100 slides, and we have 45 minutes, so let's go. Who am I? I'm Joel, my handle's TheTechromancer. I basically like to build things. This is just the one thing you need to know about me. When I was a little kid, this was me when I was 6 years old with my little Lego creation, which you can't see because my camera's blocking it. Basically, I built Legos. Now I build Python, but in my brain, they're totally the same thing. So I'm a pen tester at Black Lantern. Some of the Black Lantern folks, can I talk? Thank you. I'm the author of a couple tools, mainly Trevor Spray and BeeBot. BeeBot is the recursive internet scanner in this talk, so I'm going to be talking a lot about that. All right, quick backstory. So this was back in 2022. Black Lantern was sort of like a small pen testing firm. We're actually headquartered here in Charleston. And well, actually, this is my first BSides. I don't know why I've waited. I've been here for 5 years. I don't know why this is my first BSides. This is awesome. So yeah, definitely going to be coming more. But so we were a small firm. We had like 10 people, and we were just starting to like gain traction. So some bigger companies were starting to notice us. And so we started to do this thing where every time we take on a new client, we would do this thing called white knuckle, where basically this company would bring us in, and maybe this company already had a red team or they already had sort of a pen testing company. But our thing was basically you'd bring us in, you'd give us full reign on your external attack surface, and we would basically do this big multi-month red team, which we called Operation White Knuckle, and we'd find all the stuff that your red team missed. So we were very ragtag, kind of a ragtag group of hackers. We each had our own sort of like suite of tools that we like to run. Obviously, OSINT was a huge part of what we did, because when you bring on a company and this company has, you know, like 10,000 or 20,000 subdomains, each one having a website on it, basically you want to make sure that you find every single one, because almost always the vulnerability is going to be on the one that is hardest to find. So we all had open source tools that we used. You may recognize some of these, you know, like Amass, the Harvester. These are just tools that we ran. And sometimes we'd run all of them and just like sort of like sort unique the results. I'm sure anyone who's done OSINT has done something similar to that. But the companies that we were bringing on started to get too big for this to work. And so we basically were running up into a problem, which was that our open source tools weren't really cutting it anymore. So if you can think of like, you've seen the analogy of like external attack surface compared to an iceberg, where like the subdomains you know about are like the tip of the iceberg, and then all the ones you don't know about are down below. And so yeah, what we realized was that we were missing a lot of stuff. And this wasn't really your average pen test, so we could not afford to miss stuff. Like our whole thing was like, we need to find stuff that other people are not. So okay, so we basically hit this point that like every startup hits sooner or later, which is that we finally realized that the time was coming to an end where we could live off only other people's GitHubs, and we had to like make our own GitHub and actually write some of our own software. And since I was like sort of the builder, I mean, I wasn't really a coder, I was just a hacker, but the task sort of fell on me to like build this new OSINT tool. So I went on a quest, and I tried out all these tools, and because I really didn't want to reinvent the wheel. Like, I kind of wanted to try and find a framework to build on so I wouldn't have to start totally from scratch. So yeah, I tested out a lot of different tools, and that's how I found Spiderfoot. Okay, so Spiderfoot is very critical to understanding recursion, and it's very foundational to this talk. So basically, Spiderfoot wasn't really a pen testing tool, but out of curiosity, has anybody used Spiderfoot in here? Okay, yeah, okay. So it's been around for a long time. I think Spiderfoot's been in active development for like 12 years. But yeah, it's not really a pen testing tool. I know a few pen testers who have used it. Most of them don't use it every day because it's geared more towards intel. It's like there are lots of modules that like, you know, look up a phone number or like a human name or an address. It's kind of creepy. But yeah. What surprised me about Spiderfoot was really its design. So basically, when I looked under the hood and I started to read some of Spiderfoot's code, I was very surprised at what I saw. Because Spiderfoot's design is totally unique. It's different from any other tool. And actually, it's kind of genius. So I sort of sketched out the workflow. This is like the workflow that we use typically when doing OSINT, or sort of any external engagement where you're gathering subdomains, and then you're sort of like moving forward and sorting unique them, you know, do a port scan on them, and then after you have the open ports, you take those open ports, and you visit the websites and do all this stuff, screenshots, whatever, and then you end up with a whole bunch of URLs. So it's sort of like this one-way process. So Spiderfoot does not work like this. So instead, Spiderfoot has a whole bunch of different modules, and each module consumes a certain type of data and does something with it to discover more stuff, and then it emits a different type of data. And all of these modules, which there are like 200 of them, they all feed into each other and constantly just churn, sending back and forth until there's basically nothing left to discover. Okay, so this is an example of 3 modules. And this, again, there are like over 200 in Spiderfoot, but this is just sort of like a simple example. If we enabled 3 modules, we have an SSL cert module, Nmap, and then an HTTP module, which just visits a website. So in this example, blue is a host. And so you see the hosts are going into Nmap, and then Nmap is doing a port scan, and it's emitting red, which is open port, and the other 2 are consuming those. But then they consume them and produce hosts, which go back into Nmap. Okay, so to illustrate this, we have an example with these 3 modules. Our target is evilcorp.com. So we see the scan with that data, and since it's a host, it goes into Nmap. Nmap port scans it, finds open ports. So SSL cert visits those open ports, pulls down the SSL certificate, extracts host names. Okay, HTTP visits the website, extracts host names, end up with more hosts, which go into Nmap, which produces more open ports, which produces more hosts, which gets more open ports, more hosts, more open ports, and so on and so on and so on. And this is recursion, okay? So this is like the big idea, right? And this is why Spiderfoot is so unique. Also, this is kind of creepy, I know, but I love this GIF so much. It like illustrates exactly what I'm trying to say. All right. So, okay, now Spiderfoot wasn't perfect. Like I said, like it's not really a pen testing tool, and it was missing some functionality that we needed. So I knew like if we used it, I'd have to write a lot of modules for it. And there were some other problems, like it was also kind of slow. I knew I'd have to like probably optimize it. And it was also kind of buggy sometimes. Like sometimes it would get stuck spidering and just run forever and never stop. But like what was important was that it was a nice framework, and it was a good, solid idea. And I felt like it had a lot of potential. And so I sort of picked it as like the foundation for like my project. So yeah, fast forward 6 months. This is during COVID. So basically, like it was during COVID when I was like in my like apartment and hadn't left for like a month, and was just like getting super obsessed with Spiderfoot and recursion and just going down a rabbit hole. And it was totally not healthy. Basically, I spent a lot of time working on Spiderfoot. I deved on it, wrote a lot of new modules, overhauled some parts of the code, but sort of like kept digging myself deeper and deeper and realizing slowly that it wasn't going to work. Like basically things needed refactored that were affecting other things that needed to be refactored. And sooner or later, basically, I just realized that it would be easier to just write a new Spiderfoot, like just build a new one. Friendship ended with Spiderfoot. OK, so this is how BeeBot came into be. So this talk is about BeeBot. OK, so this is the first BeeBot scan. And this is the format of all the demos in this talk. It's going to be terminal on the right and graph on the left. OK, so what you're looking at here is a recursive DNS resolution of Tesla.com. So you can see the recursion happening like in the graph, and this is just DNS resolution. So this is before I wrote any modules. This is just like a base scan basically. But this was very promising, and I started to get really excited. But this was before I ran into all the recursion bugs. All right, so DNS was the first feature, which means that DNS bugs were the first ones to arrive. So here we go. So yeah, something is going wrong here. If you can like envision the first demo, like the first little DNS thing, that's what it should look like, right? This definitely does not look like that. So what is happening here? If we put that data into Neo4j, we can actually see what's happening. So what we did is we seeded the scan with evilcorp.com, and we had some CNAMEs. Who knows what a DNS CNAME is? OK, it's basically a redirect, right? So what we have is we have a CNAME to a CNAME, and we have this sort of chain of CNAMEs that goes around, and at the end points right back to our target. So you can see why, if you have a recursive DNS resolution algorithm, this might mess with it because it's a loop. Now, this should never exist. It really should never exist. And if you know DNS, you know it should never exist. And I beg you, please don't ever do that. But I can tell you that there are people who have done it. And maybe they're just chaotic evil. I don't know why you would do that, but we ran into it. And it really screwed with our scans. So yeah, this was sort of the first rumbling of many bugs that I would encounter. All right, here's another DNS bug. Uh-oh. OK, well, what is happening here? OK, so if you're a pen tester or if you're an OCenter of any kind, you have probably encountered this very bug. But this bug is not as bad if your tool isn't recursive. But if it's recursive, you could see that it just keeps going and keeps going. So this is an actual DNS brute force against GitHub.io. Now, GitHub.io is a wildcard domain, which means that any subdomain that you look up, it will give you an answer for. So what that means is, if I look up asdf.github.io, it'll give me an IP address back. So not a huge deal, right? Most of the time, you can just clean out the wildcards at the end, do some sort of like hacky Python script to like clean them out. Not so with recursion, because what's happening is you have subdomains of subdomains of subdomains, and every subdomain gets brute forced again and again and again, and it will never stop. It will run until the end of time. So that's what's happening here. So yeah, here's a dig showing like sort of the proof of concept. Like clearly that subdomain does not exist. There you go. There it exists. Here's an IP address. So DNS wildcards really mess with us. Doing recursive enumeration on the internet, and you run into a DNS wildcard, it is catastrophic if you don't handle it exactly right. And these were not the first bug, or not the last bugs. So yeah, they kept coming. DNS was the first one, and then once we added web, it opened this whole new dimension of terrible possibilities, and the bugs just kept coming. So Yeah, basically, there were times, for example, that we would have we'd have a scan that was running, and we'd enable the web modules. We had like a DNS brute force. We also had a directory brute force for like dir busting, and we also had nuclei. So what would happen is we'd have this customer that has a whole bunch of websites, and we would execute bbot against them, and each one would get like a dir bust against it. So we'd be getting URLs, and all those URLs would be coming in, getting fed back in, and we'd be running nuclei on them. But then we'd find out later that they'd come to us like, the websites, all of our websites are down. Why are they down? Well, it turns out that all these dir busts that BeeBot was doing, and all the URLs that were getting run with nuclei, all those subdomains pointed back to the same web server. It was just a virtual host. And so, yeah, basically accidentally DDoSed their server. So yes, that also happened. BeeBot had this problem. Basically, you'd start a scan, everything would be going normally, and maybe I'd like get up to like get coffee or something, and like when I came back, it'd just be doing something completely uncalled for, and I just had to like frantically cancel it. So I basically like learned early on that like during the creation of this tool, like it was very important that I like monitor the scans and like watch them to make sure they don't do anything crazy. So it wasn't just DNS wildcards. So cloud providers also gave us a big issue. So like, have you ever run a scan and you've accidentally, like maybe you've run like a mass or something like that, and you've accidentally included a cloud domain? So maybe you have like a storage bucket in your target list, and you're accidentally enumerating like all of Amazon AWS. So yeah, that can be a problem. Here's one that sort of illustrates the cloud issue. So this starts off as just like a normal subdomain enumeration of SpaceX, and it's not until about 30 seconds in that something starts to happen. So you can kind of see everything that's branching out from this sort of central cluster. This is all related directly to SpaceX.com. These are all subdomains, URLs, and stuff from SpaceX. But what we start to see here is we start to see this like appendage spin off on its own and sort of start growing. And this is not SpaceX.com. So what happens is this scan mistakenly recognizes that SpaceX.com is using Azure for a lot of its hosting, and it mistakenly includes Azure.com in the scope and starts enumerating all of Azure.com. Which is huge, by the way, and you don't want that. So yes, this was also an issue. There's this one time that something like that happened, and we accidentally scanned a .gov. So this was especially bad because we found a critical RCE on that. BeeBot has a few modules that will look for things like machine keys, like compromised machine keys, or like weak secrets on your web app, which a lot of the time can get you RCE. And so this was one of those cases. I can't talk a lot about this except to say that it was very awkward reporting it. And it got exploited before they could fix it. And it was a whole thing. So anyway, these bugs in general, like I had run into these before in Spiderfoot, right? They were kind of typical for Spiderfoot, but I should have like they weren't that bad. Like Spiderfoot most of the time works great, and so I think I should have like recognized some of those bugs as sort of a warning that like recursion is kind of dark territory. But I kind of had to make my own mistakes, you know, had to try for myself and get burned. All right, again, simple enumeration of SpaceX. Nothing to see here. Wait for it. Okay. What is this? What is happening here? Some of you may actually know what this is. All right. You can see very clearly that it's not stopping, and that if you look in the terminal, I know it's kind of hard to see, but on the terminal, these are all URLs, and these are all the same website. OK, so what is this? This is an infinite redirect. So there are certain cases where a site will, you'll visit a website, it'll redirect you, and because of your cookies or whatever reason, that redirect page will redirect you again. And there are cases when that happens infinitely, and every time it's a new URL. So it's like randomly generated. Again, I don't know why you would do that, but people do it, and it happened to us, and that's what happened. That's what it looks like. So recursion plus infinite redirect equals tendrils of doom. These were web bugs. We ran into a lot of web bugs. Web was probably worse than DNS. Like DNS wildcards give us a lot of trouble. Web was even worse, though. We accidentally made a web spider like 3 times. And this sounds kind of silly, but like the fact is that like when you have a recursive tool, and the recursive tool deals with URLs, all you need is 2 modules. Basically, you just need one module that visits the URL, and then one module that extracts URLs from the response, and then those URLs get fed back into the first one. It's just infinite loop, web spider. So yeah. If you're curious what a rogue web spider looks like, this is what it looks like. This is BeeBot spidering the Linux kernel documentation. You can kind of use your imagination. It could be like bacteria or like, you know, some sort of like virus replicating. I don't know. OK, so it was at this point, you know, when the bugs were sort of just like really unstoppable, that I kind of had to take a step back and ask myself like whether recursion was really worth it. Because, you know, like I started like sort of like daydreaming about those other tools I used a long time ago that weren't recursive, that worked so well and never had these problems. Like maybe, you know, maybe other people's GitHubs weren't so bad after all. So yeah, some self-doubt. I think like in the back of my head, I'd like wondered why Spiderfoot was the only recursive tool. Like OSINT is clearly a recursive problem, so like, you know, why isn't every tool recursive? Well, you know, there's a really important reason for that, and this is what I was discovering, which is that recursion is great, but the internet is not a safe place. And the argument can be made, in fact, I would make the argument, as someone who has written a recursive internet scanner, I would make the argument that the internet is 100% user input. Like it's user input all the way down. The internet was created by humans, and it's all user input, and you're ingesting into your program. So like you're basically fuzzing. Every time you scan the internet, you're fuzzing your program, essentially. So yeah, so basically I sort of in my arrogance, I kind of like thought that by starting fresh and being very careful, I could sort of avoid these problems that Spiderfoot had. But you know, the reality is that like if you build an internet scanner and you make it recursive, it's going to just do crazy shit, and there's not going to be anything you can do about it. So yeah, so I was faced with a choice. I basically had to decide whether I wanted to try harder and possibly lose my mind, or just give up on recursion and just go back to the simple linear way of doing things. And you know, the whole like BeeBot experiment would kind of just be a character building exercise. And you know, maybe I could put it on my resume as like a cool failed experiment. Who knows? So how do you do it? Like obviously I wouldn't be giving this talk if I gave up. So how do you do it? How do you tame a recursive internet scanner? All right. So unit tests. Has anyone heard of unit tests? If you haven't heard of unit tests, I envy you. Okay. But it's true. Basically, this unit tests were like a huge reason why we were able to actually get BeeBot off the ground. So every single one of those bugs that you saw, we have a unit test written for it that will fail if the bug like gets reintroduced. So basically, as we were finding these bugs, every time we found one, we'd write a unit test for it, and we'd get it to pass. And sometimes it would break another one. But this is why you have unit tests. Every time you push code, it makes it so that you have to have every single one passing before you can merge it. So yeah, unit tests, huge. Another thing also was just like learning how to think of these problems in terms of recursion. Because like we as humans, we don't naturally think recursively about problems. We sort of like, the way that we see it is like we sort of see it on the surface and we're like, okay, we don't generalize. We like, oh, I see this edge case, so I'm gonna like add an if statement that like handles this edge case. But like it's really important when you have a recursive tool to like generalize, step back and ask yourself, okay, why did this happen? And what other types of edge cases might be similar to this? And can we just fix them all in one place? So yeah, learning to think recursively, which is sort of an unorthodox way of thinking, was very key in this as well. Okay, so I want to show you something. This isn't really a demo, but so has anyone ever heard of Trickist or used Trickist? Okay. That's okay, it's pretty new. So it's basically a platform, and it allows you to automate things. So using things like bash scripts, okay? It's mainly for security professionals. The bug bounty community uses it a lot. So this, what we're looking at right here, this is a Trickist workflow for subdomain enumeration. So if we zoom in here, we can see that there are some nodes basically where you give it a list of domains, and it takes those domains and it puts them into a whole bunch of different tools. So you may recognize some of these tools. These are just common subdomain enumeration tools: subfinder, find domain, asset finder, command line tools. Runs all of them. It's sort of like if it was a bash script, you'd be like running them, sorting unique them, similar to like the diagram I showed before. But basically, it's this linear pattern where we have all sorts of things like passive enumeration, we have word lists, doing DNS brute force, doing permutations on the subdomains. And the goal, of course, is just to generate as many subdomains as possible. If you're a bug bounty hunter, this is like super important. Again, finding the most hard to find subdomains gives you an edge because those are most likely to be the juicy ones. And if you find a juicy target and you exploit it, you get paid. So, so this guy kindly made a Trickist workflow to do this. But I want to sort of like dwell on this for a second, because if we think about the way that this works, where it's sort of this one-way flow of data, where you slowly get more and more and more subdomains, where at the end you just have this big list and you're like, all right, we're done. Well, the thing is every single one of those subdomains has the potential to be used to discover more. So if we discover, like if on the last step we discovered a permutation that resulted in a new subdomain, like we'd want to start over with that. We want to go back and visit that website and do a port scan on it. We want to do permutations of that permutation and all this stuff, because every single one of those could potentially lead to more data. But in this system, there's no way to do that. So what you'd essentially have to do is you'd have to like copy this, stick it on the end, and you'd have to just do it again and again. This is an example of like things becoming more and more and more complicated because you're not thinking recursively. So instead of this sort of like assembly line of processes, instead of that, we should just have as a simple circle that just goes around and around and around. And that's what recursion is. Okay. So who would win? This ultra sophisticated pipeline or one recursive boy? All right, so I took the liberty of running a subdomain enumeration using this workflow and using BeeBot. And I just picked some big domains. So I picked Dell.com. So as you can see, BeeBot found around 18,000 domains, while Trickist only found about 12,000. And this isn't really the interesting part, because obviously I can show this graph. It's like, oh, it's a nice graph. BeeBot finds more. But if we actually look, if we this is what it looks like in Neo4j, by the way. So if we actually like diff those two lists, so we take the subdomains, we take all the trickiest ones and all the bbot ones, and we find a subdomain that bbot found that trickiest didn't, and then ask bbot how it found that. Okay, this is where it gets interesting, because you start to see these big, long discovery chains. So here's a discovery chain for this one subdomain of del.com, and this is a real discovery chain. Like, this is a real subdomain. It exists. So we seeded the scan with del.com. BeeBot hit an API. It got some subdomains. So it found a subdomain here. It found an open port on that subdomain. It visited the website. In the location header, it found a URL. So it visited the URL, and then it took that URL and it went one directory down, visited that, got a response from that, found another URL in the body, and then pulled the DNS name out of that URL, and then that DNS name had a CNAME to this. Okay? So like, how would we have discovered this without recursion, right? Like, you know, a human could have done this, but it would have taken us, you know, how long would it have taken you to do it for 18,000 subdomains, right? So this is recursion at work. Here's another one. So seeded with del.com, searched an API, found an IPv6 quad A record, found a pointer record for that IP address that pointed to another host name, found an open port on that IPv6 address, found an SSL certificate on that port, found a quad A record pointing to an IP address, looked beside that IP address and found an IP neighbor, found the pointer for that IP neighbor, contains a DNS name, which contains a quad A record, which has an open port, which has an SSL certificate, which has a DNS name. Okay, so like, these are the crazy discovery chains, and this is how BeeBot works. Every single piece of data that BeeBot discovers has this discovery chain, and it's very interesting. You can just look at it and see exactly how it found it. Here's PayPal.com. PayPal.com, over twice as many subdomains. So yeah, so again, this goes back to like the superpowers. Like this is the superpower. So if you're a bug bounty hunter, if you're a red teamer, if you're a blue teamer, you can scan your company with this, and you might actually find things you don't know about. This happens all the time. We bring on a customer, we scan their external web presence, we find a website that's vulnerable to RCE, and we bring it up to them, and they're just like, whose is this? Who has this website? They didn't know about it. You know, it was supposed to have been turned off 2 years ago, and it's still there. So yeah, if you're a blue teamer, if you're in threat intel, you can use this for collection. Like, this gives you a huge edge. And this is not a paid tool. This is an open source tool, and this enumeration was done without any API keys whatsoever. So you can literally just pip install BeeBot on your laptop and get these kind of results. So yeah, okay. So this is the takeaway. You know, if you have to remember one slide, this is definitely the one to remember. It's a Python tool. It's open source, and yeah, you can just pip install it. So yeah, it's a command line tool, but we also have I should actually say. So there are many outputs that you can output it to. So if you're like, if you're a blue teamer, if you like working in Splunk or Elastic, so you can totally output to those formats. We output to Neo4j, in addition to like the usual text, JSON, CSV, all that kind of stuff. It's also a Python library. So if you like Python, if you're a coder, you can import it and run a scan. It's like, you know, 5 or 6 lines of code. Pretty straightforward. All right, so this is my last slide. Sort of just a fun little demo, something you can make out of BeeBot. I made a little Discord bot. So there you go. You can scan stuff from Discord. All right, that's it. Thanks. All right, so I just want to say thanks to all the other people who have contributed to BeeBot. So I'm the main author of BeeBot, but there have been so many cool modules written by the community. And also I want to thank Steve Steve McAuliffe, who is the creator of Spiderfoot, who should definitely have all the credit for this design. Like, he is a genius, and he invented the whole recursive system in Spiderfoot that BeeBot makes use of. So yeah, I'll take questions now if anybody has questions. Go ahead.
What did you find of false positives? Was it proportionate to the size of BeeBot versus the other route, or is there a way of working through that stuff?
False positives, as in like domains, like subdomains, or?
For example, like when you start the subdomain enumeration, a lot of times with the word list, you pick up things that are supposedly supposed to be real, but they're just false positives that the word list picks up.
Yeah.
Does this tool work through that at all?
Good question. Yeah, and it's a huge issue, right? Because like if you ever run a mass, like you always have to clean it at the end. You always have to be like, okay, this subdomain doesn't resolve to anything, so it doesn't exist, right? So yes, I created BeeBot specifically to deal with that kind of issue. So BeeBot by default will only output things that are guaranteed to exist. In other words, it will only output resolved subdomains. So yeah, maybe it only has a text record or only has a quad A record, but as long as there is one type of record, it will output it. Yeah, good question.